Key features of Click Aggregator are: first, it uses Flink for two purposes: storing raw data in S3 and aggregating data for near real-time results. Second, it performs reconciliation using a cron task in Spark, which carefully processes raw data from S3. Third, it redirects calls to an advertisement service with a 301 status code and sends an event to Kafka. Functional requirements: redirect users to the advertisement site. Count and aggregate the number of clicks. Minimal window is 1 minute. Allow querying of aggregated data for different time frames, like last hour, last day. Non-functional requirements: ask for expected QPS and whether there are traffic peaks, low latency for analytical requests, meaning fast queries for aggregated data, scalable to support traffic peaks, fault-tolerant and data integrity so that every click is counted, click item potency to avoid miscounting, as real-time as possible, meaning aggregated data is available almost immediately. High-level design. First, the user clicks on the ad. This sends a request to the click processor service. The click processor redirects the user to the ad provider using a 301 redirect. At the same time, it aggregates the click data and stores it in the database. The query service reads data from the database when someone makes an analytical request. As you can see in this high-level design, there are a few points of failure. First, the system is not scalable because each service instance must handle all requests for the same ad, which creates a bottleneck. Second, if the click processor service fails, it will lose data since it stores the aggregated results in memory before saving to the database. To make sure we don't lose any clicks, we use Kafka to store every click event. From Kafka, Flink consumes these events. Both Kafka and Flink are fault-tolerant, so they won't lose any data. We set Kafka's retention policy to 7 days, which allows Flink to reconsume any events if a node fails or falls behind. Because our minimum aggregation window is 1 minute, we don't use Flink checkpoints. Instead, if needed, we reconsume events from Kafka to rebuild the state. Flink can also flush intermediate results every 10 seconds, so we get near real-time aggregation. The aggregated data is stored in an OLAP database, usually a SQL database optimized for analytics. To ensure accuracy and avoid missing or incorrect calculations, Flink also stores raw data in S3. Then, a scheduled Spark job reads that raw data, recalculates aggregates, and updates the database if needed.